Hi everyone, my name is Kevin George Buhain, student ID 1015-05276, and I will be presenting my assignment 1 for COMP3132. As you can see, I've already run the codes for this notebook, and I will just be talking about the output and what was happening for each question. So question 1, we start by importing Fashion MNIST dataset from QRES dataset and loading it into 4 variables: train images, train labels, test images, and test labels. And then on question 2, we print those variables that we created. So you can see that we have 60,000 image for the train image, but has a 28 by 28 pixels. Then for the train labels, we have 60,000. For the test images, we have 10,000, which also have 28 by 28 pixels, and the labels have 10,000 in it. Question 3, we check the length of each labels. Again, train labels is 60,000, test labels is 10,000. Question 4, we display the first 10 labels from the training set and from the test set. Question 5 is this shows the matrix of numbers between 0 and 255. 0 means black and 255 is white. This is the matrix of the image number 5 from the train images. So if we actually plot question number 5, it'll show this image right here, which looks like a pullover. So question 7, we check the class name of this image from question 6. It is actually a pullover. Then question 8, we test a different image. This time it's image number 500, which is another pullover. Looks like based on the image shown from question 9, and the class based also on the class shown from question 10. So question 11, we import models and layers from Keras to create a sequential model called my network. We then add a flattened layer which has a matrix of 28 by 28 to a one-dimensional vector of length 784. So next is we normalize the pixels by dividing the training and test images by 255. Question 14 and 15, we add 2 different hidden layers. First one has 512 neurons, and it's a ReLU activation. This is for the complex patterns in the input data, such as such as shapes and edges. As for question 15, it has 128 neurons, same activation, which is ReLU, giving the model capacity to separate similar classes like t-shirt and shirts. Question 16, we add the softmax activation, which has 10 neurons. So this is used as the last layer of a multi-class classifier, because it converts raw outputs and scores into probabilities that sum to 1. So here, when we check the mynetwork.summary, it shows all the layers of our sequential model. Then we compile a model for option A and show the what happened based on the fitting um, from question 18A by using option A from question 17. So we have 10 epochs, and then so what 1875 here is the number of batches from Keras, which is 32 images per batch. So if you divide 60,000 by 32, it's going to turn up to 1875. As you can see, every epoch's accuracy goes up. That means we are training it to learn better. So we also have option B for the model. And same thing happening here. So option B is a one-hot encode that labels into 10-dimensional vectors, similar to this time. Yeah, so 10 epochs as well. Accuracy is going up. So question 19. For question 19, I compare fashion MNIST with the classic MNIST digits dataset that we used in class. So MNISTs are much simpler. They are just handwritten numbers, which are visually easier to distinguish, while fashion MNIST contains clothings like t-shirt, shirts, coats, and bags, which can look quite similar in grayscale. Because of that, we usually get slightly lower accuracy on fashion MNIST compared to MNIST, even with similar models. Question 20. I look at the final result from both options, and option A, which shows which uses Adam with sparse categorical cross-entropy, achieves higher test accuracy compared to the option B, which uses RMS ROP. As you can see here, it has a lower test accuracy. So since we do have a lower training accuracy than the since we have a lower test accuracy than the training accuracies, it shows that that option A is a bit that there's a mild overfitting for option A. And I would say that's also true for option B, since we have a 0.85 test accuracy, but the training accuracy is 0.89. That is my presentation for assignment 1. Thank you for watching.